Hello again, welcome to number 2 in our carbon chemistry, and we're going to look at our first group of hydrocarbons called the alkanes. Now the alkanes contain only single bonds between the carbon atoms. That means they are saturated. Remembering what we defined saturated and unsaturated meaning in the last video? They undergo oxidization reactions, which are basically a form of combustion, so they burn, and they undergo what's called a substitution reaction, and we'll look at those in a little bit more detail shortly. But you've got to try and remember, I'll give you a list of things here and you need to remember them, this list compared to other substances like the alkenes and the alkynes. When they do burn through oxidization, they give off carbon dioxide and water, and we learnt that when we did chemical reactions, remember? Now each alkane has the same ending in its name, and that is ANE, so you can identify an alkane from its name. And we use different prefixes, meth, eth, prop, etc., to show how many carbon atoms are present in each carbon chain. And we're going to have a little video shortly in the whole naming procedures, but that's just giving you a hint along the way. And you'll find these names on your information sheet. Meth means 1, eth means 2, prop I think means 3. I can't remember right now. But we'll learn about the actual rules of naming shortly. So here are some common straight chain alkanes, starting at CH4, then the next one is got 2 carbons in its chain, then 3 carbons in its chain, 4 carbons, 5, 6, 7, 8, down to 28, and it goes on. And they each have a particular name because there is a naming convention, so there are rules on how we name these guys. Notice that the phase goes from gas, liquid to solid, so as the chains get longer in terms of carbons, the melting point and the boiling point must change, because this must have a low melting point and low boiling point to go into gaseous stage, and this must have a different melting point and boiling point, and then to be a solid at room temperature. And they have lots of uses as well. All these hydrocarbons, you're surrounded by them. They're used for thousands and thousands of different things. Okay, and notice also that the hydrogens increase by 2 as you move up, as the chain gets longer, and we'll hopefully learn how that happens. So there are homologous series. So what do we mean by a homologous series? It's a big word, it's got lots of syllables. Well, it's a series of organic compounds where each successive member differs by a common amount, which is CH2 from the previous one. Okay, and so that's why alkanes, if you go back to that table, if we went back, here we go, we're pushing the boundaries here. Whoop, we went too far. Each of these is C2 being added to each of the formulas. Okay, so that's a homologous series. And alkanes can be represented by a general formula, Cn, where n is an integer, H 2 times n plus 2. So if n is 2, this is 2 times 2 plus 2, which would be 6. Now that formula is on your information sheet, so you don't have to remember that, but that's why it's a homologous series, because it's got that formula and it differs by CH2 each time. Let's do a quick example. What's the molecular formula of an alkane having 4 carbon atoms? Well, if there are 4 carbon atoms, then N is 4, so H, the number of hydrogens, will be 2 times N plus 2, so that equals 10, so the formula will be C4H10. We won't worry about naming it just yet. So you're going to have these questions to do out of your textbook. They'll be on the OneNote, so you know when to do it, and there would be the answers for you. Now, what are the reactions that they undergo? Well, they undergo combustion reactions and substitution reactions. 2 different reactions. When they undergo combustion, the products are always carbon dioxide and water. Okay, so that's when we're burning in oxygen, O2, remember? And there we have his methane, CH4, oxygen, O2, both the gases. We're burning them, we're getting carbon dioxide and water, and then we've balanced the equation as well. And there are our two, always our products when we're burning with lots of oxygen. Now I'll put on a video on the OneNote so you can see that, one called combustion, hopefully. Now continuing, what do we mean by substitution reactions? Well, that's when alkanes react with chlorine or fluorine or any of the other group 8 elements. So also bromine is a common one that you would get as well. And they're called a substitution reaction because it's like a footballer getting substituted onto a game. In football, whichever football you want to use, rugby league, Aussie rules, soccer, union, to have a substitution, one player has to come off and one player goes on. So you always have the same number of players on the field. Same goes with the alkanes. To substitute in a chlorine, fluorine or bromine, one of the hydrogens has to be substituted. So we can have more than one chlorine or fluorine replacing hydrogen atoms. So here's an example, the most simplest one again. This carbon's got its 4 hydrogens. We're reacting with chlorine. Remember the group 7 elements form diatomic molecules, Cl2 in this case. Now in the presence of ultraviolet light, or otherwise slowly, this will occur, and one of the hydrogens, this hydrogen gets kicked off, the chlorine goes on, so that leaves one chlorine, and that forms with the hydrogen the molecule called hydrogen chloride. So it's actually making hydrochloric acid. Okay, so you should also now be able to do these questions, and again they'll be in your OneNote for you to find and do, and they would be the answers, and that's what it looks like, and there's another answer. Okay, now whilst we're here, we also need to think about what are called isomers, and more precisely we call them structural isomers. Isomers are molecules, organic molecules, that have the same formula, the molecular formula, but a different structure. Of course, we're now talking about carbon-carbon-carbon bonds. They can bond in different ways, have the same chemical formula, but have a completely different structure, and that structure can have important consequences as to the reactivity or not of the compound. So let's have a look at them. And these guys, just to stress again, are called isomers. And so here we have butane, which has the formula C4H10. We can draw it this way. Now this is a representation of where the lines represent the covalent bonds. So here we have a long chain of 4 carbons, and each carbon has 4 bonds. Okay, so we can count 4 ticks around each of the carbons, and each of the spare ticks then has a hydrogen on them. So that's butane. But we could also draw it as a chain of 3, like that, with a branch. Now this carbon is happy because it's got its 4 bonds. The carbons don't have to all bond with hydrogens or carbons. They can bond in between each other like this, and so if we count this down, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So that has exactly the same formula as this, C4H10, but very different shape. And that's an isomer. And notice it's also got a different name. So that's a little clue to us. With isomers, and when we learn how to name organic compounds, you can check whether or not you've got a correct isomer if you're asked to draw the isomers by naming it, and you should get a different name if you follow all the naming rules that we'll learn shortly. Alright, so they have different names, they have different properties because they're different shapes. Now there'll also be a video on the alkanes on the OneNote, hopefully, and you'll be able to find that. And so in the next video we'll do the next group of hydrocarbons, which are all called the alkenes. Okay.